We were discussing SVM, and today I will discuss SVM again. I will try to discuss SVM from scratch again, because I want to finish SVM today. That's why I combined two lectures together. So I will start from the very beginning of the SVM, rewriting everything that we have derived so far, and we will continue from there onwards. Its derivation is not complicated, not at all. So if you are not understanding, you are missing some simple step. So raise your hand and ask questions. Make sense? Okay. So the idea is the following. You are given, again, I am discussing everything in the context of binary classification, and then you know how to extend it to multi-class settings. So the idea is the following. You are given some data points. Like this, and you want to find out a linear separator. But a linear separator, if your feature space is two-dimensional, the linear separator is a line. If your feature space is three-dimensional, your linear separator is a plane. If your feature space is more than three-dimensional, then your linear separator is termed as hyperplane. आप नौकरी आते हैं क्लास में? आज just for the sake of recording as well, so we have काफी ज़्यादा class this is not because of the glory of SVM. This is because today we have attendance quiz. Just to mention this. Anyways, okay. So if your feature space is more than three-dimensional, then your linear separator is termed as hyperplane. Okay. Okay. So आपने linear decision boundary ढूंढनी. Linear decision boundary. In the case of two-dimensional feature space, the linear decision boundary is just a line. In the case, if you have your feature space is three-dimensional, your linear separating boundary is a plane. And for the feature space that is above them, three-dimensional, the linear separating boundary is called hyperplane. You can call it plane, but the technical term is hyperplane. That you cannot visualize, okay? Okay. Now, there are other linear algorithms, there are other linear discriminants, जो कि ऐसी boundary ढूंढते हैं जो वो linear हो. The merit of SVM is somewhat different. The goal here in SVM is the following. Given the points, और मैं फिलहाल assume कर रहा हूँ the points are linearly separable. फिलहाल मैं वो setting assume कर रहा हूँ जिसमें there exists a linear separator that separate each and every data point. फिलहाल मैं linear separability assume कर रहा हूँ. We will relax this assumption after we grab everything. ठीक है, हम देखेंगे कि इस assumption को relax करना is not correct. Clear? So data is linearly separable, which means there exists a line. In the case of 2D, there exists a line that separates the data. The one class completely on the one side of the line, and the second class is completely on the other side of the line. Yes? In the case of two-dimensional. In the case of three and more dimensional, everything that is class 1 is on the one side of the hyperplane, and class 2 is on the other side of the hyperplane completely. Yes? That means the data is linearly separable. Clear? Okay. Now, there might be several boundaries that you may come up with, and all of them are perfect linear separators. The goal of SVM is to find out a boundary, to find out a linear separator that maximizes the margin. And the margin is defined as a separator with the margin is the distance of the closest point from the boundary. That is called the margin of that boundary. Clear? So you come up with different boundaries. You cannot change the points. The training data is given to you. That's the training data. You cannot change it. Make sense? boundary, that boundary, and that boundary. Make sense? SVM idea is to select a boundary that has maximum margin.
Yes.
And the margin is defined as the distance of the closest point to the boundary. Either side of वो हो सकता है इस class का, इस class का. We are not going to discuss the closest point एक से ज़्यादा हो सकते हैं. If there exists a closest point, whatever the closest point हमेशा exist करेगा. So the closest point, whether one or more, the distance of the closest point from the boundary, that is defined as the margin. Clear sir? Clear? वो closest point एक class का हो, दोनों का distance same हो. For simplicity, we are not going into that. The closest point, whichever is that, the distance from the closest point to the boundary is called the margin. And we are after finding out the boundary that has maximum margin. Make sense? If you come up with one boundary, उस boundary के लिहाज से जो closest point होगा, उसका जो distance होगा, that is called the margin of that boundary. अगर आप boundary change करते हैं, तो boundary change करने के साथ ही हो सकता है with a different boundary you have a different closest point now. और जो भी boundary आप लेके आते हैं, उस boundary के जो भी closest point है, उसके साथ जो उसका distance है, that is the margin. Come up with a boundary with maximum margin. Yes, no? That's the idea. That's completely is the idea. Clear? Okay. So in this particular case, this black line, this point is closest to the black line, and this is the margin. This is the margin. And margin means in this particular, you have this particular area. Still you are on the safe side. अगर आप किसी class का कोई point इसके अंदर भी आ जाए, as long as so you have this margin still, कि आप इसमें error नहीं करेंगे. Make sense?
Yes, sir.
That's a safety region, so to speak. So more margin means more, you have more safety region. If on the other hand, आपकी boundary इस तरह की हो कि you are very very close to the points, then if a new test point comes in just right here, very close to the boundary, but on the other side, you'll make an error because you never left a safety margin there. Yes, no? That's the idea. If idea is clear, I'm going towards the math. Yes, no?
तो वर्ड दैट के अभी तक हमने वो ये चीज़ की भी पता नहीं चला कि बाबा जी वो कैसे देंगे मेरे को लाइन.
Sorry?
और सेपरेटर लाइन हमें कैसे मिलेगी ये नहीं पता चला.
अभी नहीं हमें पता. लेकिन हम जो भी लाइन हो, जो बाद में हम जो भी प्लेन हो, जो हम फाइंड आउट करना चाहते हैं, उसकी ये प्रॉपर्टी हो कि there does not exist another plane having better margin than this.
मार्जिन सर जितना ज़्यादा होगा उतने बेटर.
मार्जिन जितना ज़्यादा होगा उतना ज़्यादा सेफ्टी रीजन आपका हाई है. Yes. So SVM says the maximum margin you have, the best separator you have. Make sense?
क्लोजेस्ट पॉइंट जो है आपके मार्जिन से जो क्लोजेस्ट पॉइंट होगा तो ऐसा हो सकता है कि वो
Just listen ये सुने इनका सवाल.
जो क्लोजेस्ट पॉइंट है मार्जिन से वो ऐसा हो सकता है वो आउट.
That's a very good question. What if the closest point is really is an outlier? So I will discuss that outlier problem along with the non-linear separability after this derivation. So another concern might be, what if the data is not linearly separable no matter what we do? No matter what line we come up with, the data is not, there does not exist a linear separator. No matter what we do. Then in that case, what should we do? That's one concern. The other concern that the student just raised is this, that you have several points like here, and it just turned out, and the other points are here. If you come up with this, you have a huge margin. It just turned out that one point is here. Okay? And just because of this point, you shift your line here to increase the margin. And that point will be termed as outlier. Should you consider this point to be the closest point, or you will ignore it? So we will discuss this formulation after the clean formulation. Now we are discussing the clean formulation. The linear separation is there. Number two, there exists no such outlier. The closest point is the good point. Then we will include, okay, what if linear separation is not there? What if there are points that should not be considered as closest points? That might be termed as a, okay? So we'll discuss that. So that's a good question. That's very, very concerned. I will discuss that. So far, Linear separation, the closest point is not an outlier, it is considered a good point. चलिए आगे. Okay, here is the equation of the plane. W transpose x plus b equals to 0.
सर ये ब्लैक से लिखनी है, रेड नजर नहीं आ रहा.
Okay. Here is the equation of the plane. W transpose x plus b equals to 0.
Yes.
Clear? That's the let's say for the given data points, I give you a plane which is a separating plane. Along with the separating plane, I provide you that this is the closest point to this plane. Make sense? So this is the plane, for example. Let me call this plane as W1, B1 and that. And let me call the closest point to this plane, let me call that point as XC1, YC1. That's the closest point to this point. Make sense?
Yes.
And why, I mean, it might be of class 1, it might be of class -1. Remember in SVM, we initialize the labels as 1, -1 rather than 1, 0. Although जो मैंने lab upload कर दी है उसमें there is no change. आप 1 और 0 की form में submit करें and code will automatically do stuff for you. It will convert everything from 1, -1. It will again give you result from 1 and 0. So the पिछली formulation आप use करें वो change नहीं होगी. लेकिन inside it converts, it replaces zeros with -1. So whatever the class of this point is, assume this is some plane and this is the closest point to it. Clear? And this is some other plane. Another plane is W2 x plus B2 equals to 0. And the closest point to this plane is XC2 YC2. Make sense? Closest point to this plane, and this is the plane and this is the closest point to it. Let's say we want to decide whether we want to pick this plane or that plane. Let's say SVM has to decide, I'm going to pick this plane or that plane. So I'm given two planes and their closest points. Which one I will pick? मेरी बात समझ आ रही?
Yes.
और बाद में हम देखेंगे कि actually there are infinitely many planes और हर plane का कोई closest point and stuff. So if we can compare between two, we can compare between everything. Yes? Okay. Now, the distance of this point, let me compute the margin of this plane. Let me compute the margin of this plane. The margin of this plane is W1 transpose X C1 plus B1. मैं absolute value नहीं लगा रहा. Clear? Just to compute the sign distance. Yes? और अगर मैं distance को बिल्कुल compute करना चाहूँ, let me multiply this with C1. अब अगर ये वाली value minus थी और ये भी minus है, then this will become positive. अगर ये वाली value positive है और ये भी positive one है, then again it is a positive number. So वो जो absolute ने काम करना था वो मैंने इससे कर दिया होगा. Remember this?
ये समझ नहीं आया ये बात है.
So अगर ये class 1 से है, अगर ये class 1 से है, then this number is positive.
Fit.
Then 1 times the positive number is positive.
Yes.
अगर ये point class -1 से है,
जबरदस्त.
then this number is -1 and this number is some negative number. This is some negative number. And negative number times -1 is again a positive number.
जबरदस्त.
Make sense? So this is a positive number that describes the margin. And not just this one. So this multiplier is just replacing the absolute value. Clear? And then we have this W1 magnitude. This is the margin of this plane. Make sense? Because this is the closest point to this plane, and the closest point actually defines the margin. So let me call this as M1, margin 1. Clear?
Yes.
Yes, no. Okay. Then we can compute the margin of class 2, which is YC2 times this is margin of class 2. Yes, no. Okay. If in the word, if there are only two boundaries, this one and that one, and we have to decide one from those, then the SVM will pick M1 if M1 is bigger, SVM will pick M2 if M2 is bigger. That's the goal. Yes, no.
Wait a minute.
मार्जिन प्लेसमेंट कर रहे हो तो आप नहीं कर रहे
मार्जिन डिफाइन होता है एक प्लेन का. डिफाइन कैसे होता है? उस प्लेन से क्लोजेस्ट ट्रेनिंग डेटा पॉइंट उससे कितना दूर है. ये जो डिस्टेंस है, दिस इज कॉल्ड मार्जिन. आप कोई और प्लेन लेके आएंगे, उस प्लेन से कोई पॉइंट होगा जो क्लोजेस्ट होगा, वो उससे कितना दूर है, वो उस प्लेन का मार्जिन है. सो द मार्जिन इज द प्रॉपर्टी ऑफ द प्लेन, नॉट ऑफ द पॉइंट.
सर ये हम मार्जिन निकाल रहे हैं,
Yes.
इसमें हमारे पास एक्चुअली हम दो क्लासेस को सेपरेट कर रहे हैं, तो हम
So we are assuming that the plane is a separator.
एग्जैक्टली
ये हम पहले से assume कर रहे हैं. It is a separator. Yes.
तो जो मार्जिन होगा हम उसको बढ़ाते बढ़ाते क्लास 1 से बहुत आगे तक ले जाएं कि वो क्लास 2 के करीब आ जाए. तो इसको ना दोनों को चेक करेंगे, दोनों डेटा पॉइंट्स.
देखिए, अगर आप मार्जिन बढ़ाते बढ़ाते अगर आप बाउंड्री को शिफ्ट करते हैं, ठीक है, तो अब उसका क्लोजेस्ट पॉइंट कोई और हो जाएगा. अगर क्लोजेस्ट पॉइंट कोई और हो जाएगा तो हो सकता है वो मार्जिन कम हो जाए.
क्लोजेस्ट पॉइंट पे ये रिस्ट्रिक्शन नहीं है कि वो क्लास 1 से
क्लोजेस्ट पॉइंट पे ये रिस्ट्रिक्शन नहीं है वो किस क्लास का है. इट इज अ क्लोजेस्ट पॉइंट. So that's why we are multiplying this with label. In whatever class a closest point is, one can easily prove कि वो अगर एक क्लास का है तो दूसरी क्लास का भी एटलीस्ट कोई एक पॉइंट जरूर होगा जो उसके उतने फासले पर होगा. बट हम उस डिस्कशन में जाते हैं. लेट्स मेक इट वेरी सिंपल. देयर एग्जिस्ट अ क्लोजेस्ट पॉइंट जिससे उसका मार्जिन डिफाइन होता है. इफ यू शिफ्ट द बाउंड्री then the closest point may change and the new closest point will define the margin.
Yes.
इट मींस कि बेसिकली एसवीएम सिर्फ बाइनरी क्लासिफिकेशन में चलता है.
No, we can extend it to multi-class. So its initial setting is binary. Once we are done with binary, then we can extend the binary classifier to multi-class, as we have done with linear regression. We have done with logic.
And that multi-class classifier will be based on this
Will be based on binary classification. Yes. Actually, every. Okay. So far, so good.
Yes.
Now assume that this numerator in this fraction, the margin is defined by two numbers, a numerator and a denominator. Here a numerator and a denominator. Yes. Assume that this numerator value is 5, let's say, and the denominator value, so this particular value, this number is 5, and let's say the denominator value is let's say 7. So the margin is 5 over 7. That's the distance. Make sense? Okay. Here assume that the numerator value is 9 and the denominator value is let's say 10. And the margin here is 9 over 10. Make sense?
Yes.
Is that okay? Yes, no. Now, obviously, you will see whether 9 over 10 is bigger or 5 over 7 is bigger. Whichever is bigger, you will choose that. Yes, no. So far, so good?
Yes.
What I can really do is the following. I can rewrite, ये मैं अभी यहाँ पे डाल रहा हूँ. I can rewrite W2 dash as 1 over 9 W2. Just I'm defining another W, which is just a scale factor of W2. This is the actual W2. I'm defining this one. And B2 dash as 1 over 9 B2. Make sense?
अच्छा
And I replace in this equation W2 dash in the place of W2 and B2 dash in the place of B2.
अच्छा मतलब
What
कट
I am saying is, doing this will not change the plane. And here is the proof. If I have 2x1 plus 3x2 plus 4x3 minus 9 equals to 0, here 2, 3, 4, they corresponds to W, and minus 9 it corresponds to B. Now, you can multiply the whole thing by any number.
the plane will remain the
The
same.
plane does not change, and any point to the plane, because the plane does not change, the distance of the points from the plane does not change.
Yes.
Yes, no?
Yes.
Yes, no?
Yes.
So which means if I replace this W2 with, so if I just write 1 over 9 here,
Yes.
let me just make things simple. If I just write 1 over 9 here and 1 over 9 here, and कुछ भी change नहीं किया, yes?
Yes.
But by writing 1 over 9 here, this numerator becomes 1. और अगर मैं इसको 1 over 9 की जगह इसमें just लिखूं W2 dash, yes? Make sense?
Yes.
Is that okay? मैंने बेसिकली 1 over 9 से मल्टीप्लाई कर दिया। तो प्रीवियस इक्वेशन से 1 over 9 से उसको भी ऊपर भी मल्टीप्लाई कर दिया।
सही हो
अब हुआ ये डिस्टेंस चेंज नहीं हुआ ना प्लेन चेंज हुआ है। मैंने सिर्फ न्यूमरेटर को 1 कर दिया और डिनोमिनेटर की वैल्यू जो है इस वक्त वो हो जाएगी 10 over 9. Make sense? And the total distance is again 9 over 10. Yes, no. Similarly, I can do the same stuff with this. I can write this W dash, B dash, and that. And this numerator will become 1. And the denominator will become 7 over 5. Yes, no. Now, if you want to see whether you are choosing this plane or that plane, all you have to see is which denominator is smaller, because you have fixed the numerators to 1.
Yes.
दो फ्रैक्शंस को आपने कंपेयर करना था, आपने इसका भी न्यूमरेटर 1 सेट कर दिया स्केल करने से, इसका भी न्यूमरेटर 1 सेट कर दिया आपने स्केलिंग कर दी, ठीक है? तो दो फ्रैक्शंस को कंपेयर करना है, दोनों के न्यूमरेटर्स 1 है। Which one is bigger depends upon the denominator. जिसका डिनोमिनेटर छोटा होगा
वो बड़ा होगा.
Is that okay?
Okay.
Yes, no. Yes. So the question is, आप simply क्यों नहीं देख रहे कि ये फ्रैक्शन बड़ी है, ये फ्रैक्शन बड़ी है?
बिल्कुल ठीक बात है.
By fixing the numerator to 1, by fixing the numerator to 1, that I can always do. I am switching from a fraction comparison to a number comparison. This number is bigger than this one, or that, whether a fraction comparison. और जब ये फॉर्मूले में आएगा तो फ्रैक्शन will make a trouble, and a number compared to another number will be.
But that number will be a floating value, right?
That will be a floating.
But sir, अगर हम
तो वो भी फ्रैक्शन ही है. तो वो भी फ्रैक्शन ही है.
Oh, fraction not in the term of I mean, this is a number and that is a number. When W is a variable and this W is a variable. Now you have some equation of the variable divided by some variable. So this fraction is no longer a very linear form or stuff like that. So the comparison will not be that easy.
यदि ये उसे करना तो बैड लग जाएगा, तो हम इसको फिर मतलब आपके पास में लगी है, दैट सब तो ये आसान तो है,
लेकिन समय आप आपको और समझिए.
हमें तो मैथ करने में आसानी हो जाएगी, मैटलैब को इसमें क्या आसानी
So
करेगी?
MATLAB को further आसानी हो जाएगी क्योंकि इससे जो आप optimization problem build up करेंगे, that will be having a form that can be easily optimized.
वहाँ तो वैसे में लेस देन ग्रेटर का साइन लगाना है तो उसमें ऑटोमेटिक बता देगा कि
Not that straightforward.
तो वो जो आप जो चीज़ आपके जहन में ना आपको लग रहा है कि वो चीज़ स्ट्रेट फॉरवर्ड नहीं है, वो समझ लग रहा है कि आप किस लिए करें करवा.
Basically, I'm putting this problem in a form that has a famous solver.
Okay.
So one solver is gradient descent. That is the solver. Gradient descent will not work here. मैं अभी बताऊंगा आपको. आपने जब प्रॉब्लम सेटअप करनी है, आपने कोई ऐसा प्लेन ढूंढना है ना जो मैक्सिमाइज करे मार्जिन को. So there will be a problem that has to be maximized with respect to variables. Taking the derivative, put it equal to 0 and apply gradient descent will not work here. So I will make a particular form that is another famous form. Make sense? और उस फॉर्म की तरफ मैं जा रहा हूँ. और उस फॉर्म को हम ब्लैक बॉक्स के तौर पर ट्रीट कर रहे हैं. क्वाड्रेटिक प्रोग्रामिंग में थोड़ी देर बाद उसको इंट्रोड्यूस करता हूँ. Make sense? लेकिन अभी तक मैं ये कह रहा हूँ, अभी तक आपका क्वेश्चन ये है कि क्या हम ये क्यों कर रहे हैं? अगर मैं इसका क्वेश्चन यानी मैं काउंटर क्वेश्चन दूँ और मैं आपसे कहूँ मैं जो कुछ कर रहा हूँ क्या उसमें कुछ गलत किया है?
नहीं.
Can I do it? I can always do it. यानी एक बंदा है वो कहता है दो फ्रैक्शंस को वो कंपेयर करता है, उसके बाद न्यूमरेटर वैल्यू है, न्यूमरेटर वैल्यू है, न्यूमरेटर वैल्यू है, न्यूमरेटर वैल्यू इन कंपेयर्स. दूसरा बंदा को क्या करता है कि दोनों के न्यूमरेटर्स को 1 सेट कर देता है और डिनोमिनेटर को अकॉर्डिंगली स्केल कर देता है और वो डिनोमिनेटर्स को कंपेयर करता है. सो बोथ आर डूइंग सेम थिंग.
Yes.
हाँ, दूसरा ऐसा क्यों कर रहा है? I will answer that question when I will make the form to a form that is acceptable to several solvers. Make sense?
ठीक है.
Yes.
सर ये बात को स्कैन का एनर्जी के साइड
Sorry.
for one has m and has a
So I have just taken this thing. I replace my W with 1/9 and I replace my B with 1/9. तो अब ऊपर की वैल्यू 1 होगी. लेकिन जैसे ही मैंने नीचे W की जगह पर W2 डैश किया, that उसकी नॉर्म क्या होगी 1/9 टाइम्स डिवीजन नॉर्म. सो पहले वो वैल्यू थी 10 और वैल्यू होगी 10/9. यस नो?
Yes.
अच्छा, अब जरा ज़हन में रखिएगा. और बाय द वे ये ऊपर 1 सेट करने से I have not changed the boundary. That's the same boundary. Make sense? ये आप पूरी अल्फा से मल्टीप्लाई कर दें इक्वेशन को, इक्वेशन वही रहेगी जो पॉइंट से उसके इस प्लेन से डिस्टेंस वही रहेंगे. यस नो?
बिल्कुल ठीक.
सॉरी कितना है? भैया से प्रेजेंट रिकॉर्ड
हाँ.
लेकिन क्या वो लोग कह रहे हैं रिकॉर्डिंग का अपलोड कर रहे हैं?
यार ये इलाज नहीं.
करें यार, लोगों ने इल्म हासिल करना है. तो ये बात है.